Dance Equations for me is about taking everything I've done as an artist to the next level, so that my inspiration as a creator goes a step further. I really enjoy teaching in schools. I taught in schools for many, many years through many different programs. And I found that my reach into the school was only that day, or if I inspired some students, they might take dance class out of that environment. But it was a great experience, and I'm sure every kid enjoyed it. But how do I take the arts and make a greater influence? I had become very inspired with mathematics and science, and so that really fueled my company work of what I was choreographing. And again, I wanted to take it a step further. How do I help people understand how I'm mixing math, science, and dance, philosophy into my work? And because I've always taught children, it seemed like a natural way to move forward to write this program. So what Dance Equations is a program that teachers can teach themselves. What is unique about the program is that because I am mixing math and dance together, there's a whole other level of cognitive learning that goes on in that process. What is unique about the program is that it's very much an authentic dance program and an authentic math program. The full spectrum of the mathematical curriculum can be taught with this program. As a scientist, discovering something like particles hundreds of years before we can actually prove those things, it's amazing, some of the concepts of, I think this is how gravity works. How can I prove it? That takes a really creative mind to be able to do, and that's what I want to do. I want to bring that in, but also make it wacky, make it fun, have a good time, get moving, get exploring, and take some of the kids that have a hard time sitting down with a pen and a paper and take them to the next level. When you look at something two-dimensional, like a triangle or a cube, I mean, are you really experiencing what it is to move in 3 dimensions? Are you really experiencing that shape in 3 dimensions? When you take it to movement and you take right away into making wacky, crazy shapes with your friends and making a flip, a rotation, a translation of something like that in a space, you immediately can grasp what it is that the kids are doing. What are they understanding? Can they take it further? Can they make it symmetry in motion? Can they make symmetry in their own body? Can they make symmetrical shapes? Can they make angles? There's so much you can bring into it that it becomes a jumping off point. So beyond movement, the first resource of the program is that jumping off point. It's that place that you can study and learn. How do I teach dance? How do I incorporate math? Here are the lessons, here are the worksheets, here are the resources, here's something I can demonstrate to the students. It's all there. From there, you can start introducing your own lessons. Oh, I think I could pull in a unit on Mayan culture into this. I think I could pull in, we're studying snowflakes. The benefit of that is that we've done dance in the class. We've done math. Then we've brought in another theme or a story or a concept, and at the same time, the winter concert at school is coming up, and the teacher's required on top of everything to come up with a dance or something to present to the school, to the parents. And now you've got a dance. It's already done. So you've accomplished a huge amount of resources, you've accomplished a huge amount of the curriculum, and you have something to present at the end of it. You have something to give back and say, hey, we did this. You have something to show the parents. And you save a lot of time and a lot of work.